Welcome to the physics of deltoids. Hey there folks, today I want to talk about the deltoid. Now you probably learned about the deltoid in gym class with Mr. Weiss, but now hold up right there because the deltoid is more important than you think it is. As a matter of fact, the deltoid is the whole reason this guy's arm doesn't just fall off. The deltoid is the muscle that exerts the force necessary to keep your arm straight. I mean, that's the only reason this guy doesn't fall like a pancake. Let's go ahead and check out the physics and the math behind how much force the deltoid actually exerts to make your arm straight. Let's go check it out. Alright, let's check out the physics and the math behind how the deltoid actually holds up your arm. So first thing we gotta do is draw a picture. So here, as you can see, I'm no Picasso, but this right here is your arm. Now, your arm has three big parts. Number one, your shoulder. This is where your deltoid is located, right? Now, your shoulder is at a 15-degree angle to your arm. Here's a few more things you should know to find how much force the deltoid exerts to hold up your arm. First and foremost, the center of your arm, also known as the center of mass, is going to be 17 centimeters from your shoulder. You should also know that the length of your arm should be about 38 centimeters. And finally, your arm, if you're the average male, should be about 4 kilograms. Alright, now we finally have enough information to start solving this problem. So, first and foremost, what you should know is your arm. When you think about your arm, what do you see? It rotates, right? It rotates around its center of mass. So, when it comes to physics, there's a synonym for rotation. We like to call it torque. Torque is the amount of force you need to rotate something. You need some force to move something. You also need some force to rotate something. That's called the torque. Now, your deltoid exerts a torque. Let's call that the torque due to the deltoid. That torque is going to equal the torque due to your arm. Since your arm is not rotating in this rest flat position, the torque exerted by the deltoid and the arm will be the same, aka 0. Now, we can do some more. What is the torque actually equal to? Well, torque, remember, is going to be the cross product of the force exerted by the deltoid times the radius of the deltoid. That's going to equal the force exerted by your arm cross the radius of your arm. So let's expand this using the definition of the cross product, which tells us that this was simply FD/RD sine of theta, theta sub d. How about this? Well, this is simply the force due to your arm times the radius of your arm times sine of theta of your arm. Now we can start plugging and chugging, folks. So, first and foremost, the force due to the deltoid, that's the quantity we want to calculate. Okay, so keep that in mind. How about this, the radius of the deltoid? Well, the radius is simply the distance the deltoid is away from your center of mass. So that's going to be 17 centimeters. Convert that to meters and you'll get 0.17. Sine of what? What's the angle of the deltoid with respect to your arm? Well, it's simply 15 degrees. So let's plug that in, 15 degrees. Okay, and that's going to equal the force due to your arm. And of course, remember, force is equal to mass times acceleration due to Newton's second law. So what's the mass of your arm? The mass of your arm is 4 kilograms. What's the acceleration of your arm? Well, remember, the acceleration due to gravity is 9.8 meters per second squared. And finally, sine of what angle? Well, sine of 90 degrees. As you can see, your arm is at an angle of 90 degrees with respect to your vertical. So what are we going to have? Well, solve for the force due to your deltoid, and you're going to end up, if you just plug on and chug all of this in, we're going to end up with 4 times 10. Sine of 90 is just 1 on the numerator, divided by 0.17 times sine of 15 degrees on the denominator. Plug and chug that in, and you're going to find that your deltoid exerts 340 newtons of force. That's a lot of force for one thing. That means your deltoid has to exert this much force whenever you hold up your arm like this. That's why it's so hard to hold up your arm like this for like 1 hour. Because your deltoid has to exert this much force, 340 newtons, every single second. Think about that the next time you try to high five somebody. We'll check you out in the next episode.